quadratic. The first thing, talk about these two words, linear and quadratic. We've done linear equations. Here we're calling them functions, but it's the same idea. Linear functions, linear equations. If we were to graph a linear equation, what would the graph look like? These are the ones we graphed in the first half of the chapter. Linear is your clue, Izzy. Right. A straight line. Right? This was when you either used slope-intercept form, or you made the little chart with the x and y values, and I always said get 3 points, so you'd have a straight line. So your graph for that would be a straight line. The equation, what I'm going to try to do here is just show you what these would look like, and then we're going to be spending time today talking more about the quadratic side. The linear ones we've done. We get a straight line through whatever method we're using. And the equation might look something, I'm going to put one that's in slope-intercept form. They don't have to always be in this form. But it's an example. Notice there's no exponents. We have a y and an x. And those are the kinds of ones that we have been working on the most. Now, quadratic functions or quadratic equations. Same idea here. When we talk about functions, these are usually equations. So, first of all, the graph. This is what we're going to be working on today. So I know this won't make much sense just yet. It will not be a straight line. It will be a shape that is called a parabola. Parabola. Not parabola, not Ebola. Parabola. Is that somebody in here? Tapping? What is a parabola? Well, it's either a U shape like this. Now it can get wider, it can get skinnier. It could also go upside down. But either way, just like on a straight line, it would go infinitely from the ends. So I put those arrows on it. But it could be an upwards facing U, an upside down U. Again, it can be much wider, it could be much skinnier. There's a lot of variations there. But that's the basic shape of a parabola. And we're going to be graphing these today, but I'll show you a method for how to do it. Now, what does the equation look like? We have not graphed these yet. A sample of an equation. Y equals x squared minus 2x minus 2. There's our good friend, the trinomial. Now, we've been looking at it, the trinomial as just an expression like this without a y equals. If it's a quadratic equation, we need to have the equal sign to have it be an equation. The y, think x and y values, just like we graph. This could work. This will work the same where we are picking x values, plugging them in, and we get out a y value and we plot the points. The method for doing this graphing is very similar, but there's a few slight differences. So first of all, let me just say that on the test, there are a couple questions where it just shows different equations, and you just have to label them, quadratic or linear, quadratic or linear. And this would be a good place to look to know what that should look like for which kind it is. So, as I mentioned today, we are focusing on the quadratic equation. There's a couple things that I need to give you first, and then we're going to get to our little square of graph paper. This isn't going to make much sense as I give it to you first, but we'll get to it. Let's start with the x coordinate of the vertex. Now, you might be thinking already, what's a vertex? X coordinate would be the x value in an xy pair, right? Let me come back up to my little drawings up here of the parabola. The vertex is going to be either the highest, if it's upside down, or the lowest point. So I'm going to come back now that I'm giving you this vocabulary word and say vertex. Again, either the highest or the lowest point. Think of a vertex on an angle, right? It's the corner. Well, this doesn't really have corners, but if we straightened out those sides, it would make an angle. So, one of the things you need to do is to figure out where is this vertex point. And there's a little formula that we use for this. Negative b over 2a. This formula. Now, b and a, what? Let's think back to our trinomial. We're actually going to do this one that I had started with up here, so I'm going to rewrite it down here. But I'm going to put in the ABC. We talked about this back in chapter 5 when we were factoring these. Remember, factoring a trinomial means reverse FOIL? We're not doing that today, don't worry, no factoring. But the original form of this, and again, we didn't have the y squared. When we started this in chapter 5, we didn't have y squared, we just had the trinomial. But it looked like this. Okay, so again, this would be, if you want to look back at this chapter 5, we looked at, when we were factoring, we were looking at stuff like this and trying to figure out how to factor it. The a is always the value that's multiplied by the variable that's got the exponent, the squared. The b is always the value that's by the plane x. And the c would be the plane number. Now, we're not using c in this formula, but that's just a little reminder. Does that sound familiar? A little bit? Oh, no, you guys already forgot all of chapter 5. Oh, no. This part, again, and I know you probably don't want to spend the time to go look, but I'll just show you right here. Here was 5, 9. Right, so there it is with the A, the B, and the C. We did do it. I know it was a little while ago now. But this is a reminder of what this is, where the A and the B come from. That's what these variables are. This A and this B means look at the equation, find the A, what's multiplied here, find the B, and we're just going to plug them into this little formula. So now, let's go back, and we're actually going to use, it's off my screen here, but this one is going to be our actual equation. Y equals x squared minus 2x minus 2. So if we compare that, my A and my B, and I'm going to plug those in to this little formula. The formula has the negative out front. We can end up moving it somewhere, a numerator or a denominator, but for now we're just going to keep it out front. The important part is it's not related to the A or the B value. If one of those is negative, they keep their negative. Can somebody tell me what's my A value? If we start with A, it's over 2 times A. What's my A value here? Vincent? Yeah, the invisible 1. It's the only number we don't write down, other than sometimes 0, but if it was 0, this would all be gone. So A is 1. What's my B value? Luke? Good, negative 2, keeping that negative with it. Well, let's simplify this. I'm going to keep my negative out front. I have negative 2 over 2. If I wait to hold off on that last negative, negative 2 divided by 2. Right? The opposite. What is negative 2 divided by 2? And if you need me, I can write that down. Negative 2 divided by 2. What is that? Jim? Negative 1. This says the opposite of negative 1, positive 1. Now, what does that mean? I'll show you. We'll get to that in just a second. Now, this is going to be your first step. I want you to find the x-coordinate of the vertex. Now, what that means is that that high or low point is going to be at the location 1, comma something. Okay, we found the x-coordinate. We only have that. We only have the x. We don't have the y. Let's think about what we did with plain old linear equations. We plugged in an x value and got out a y value. Now my black pen's running out, so I'm going to switch. What x value do we want to start with? We want to start with the vertex. How do we find the vertex? Using this little formula to get the x value. I need to still find the y value. I'm going to start with this. I'm going to plug in my x value for this vertex point. This is going to tell me how to start my graph. I plug in the 1 for every x. 1 squared minus 2 times 1 minus 2. You can hopefully see here, this is sort of like what you were doing yesterday when you were given the x values and you had to plug them in and get a y value. Be careful with your PEMDAS and your negatives. This is 1 minus 2 minus 2. If I add the opposite all the way across, I get -3. Now I did that math pretty quickly. You're going to want to make sure that you do it properly, slowly, carefully. All right, this is my vertex point. I plugged in 1, we do the math, we get out -3. Now it's time to start graphing, and then we'll come back to our chart. On your little square graph paper. Now, we can paste it in later. Give yourself first an x and y axis. And then we're going to plot our first point, which was 1, -3. So I went over 1 on the x, down -3 on the y. I know this takes a while, guys. The good news is it means I don't give you very many problems to do. Because these are definitely more complicated than the straight line. Okay, now there's something else that is going to help you graph this. Once you find your vertex, I want you to do a dotted line, dashed or dotted, not solid, all the way down through the vertex. This is what's called the axis of symmetry. I'll show you what that means as we get going with graphing. But the good news about the axis of symmetry is it's going to make graphing easier. It means we don't have to pick so many points. Because we have to pick some values for x, plug them in. We need more points. I don't know what kind of U this is going to be. Is it going to go up? Is it going to go down? Is it going to be really wide and open? Is it going to be skinny? So we're going to need more points. But the axis of symmetry, think of it as an axis like the Earth is on an axis, right? We rotate around the axis. This parabola is going to be symmetrical on both sides, meaning exactly a mirror image. Okay, now I need to move this off my screen. I'll put it back up if you're not done when we get to graphing it. Now, the math part on this chart, I'm going to go a little quickly on the PEMDAS because I want to save time just to show you how to graph. So I'm just going to be giving you the answers. On your work, for homework, you need to do this step like I did here. So for example, the next point I'm going to pick is going to be, let's see, I've already got 1. How about if I do 0 for x? Now I'll just briefly set it up. 0 squared minus 2 times 0 minus 2. I'm going to leave all the PEMDAS, all the calculations for now. Just trust me when I tell you the answer it will come out to be a -2. So my next point, this part is similar to the straight line. It's just that we have that exponent in there. You pick a value, you plug it in. So if we plug in 0 for x, we get out -2 for y. Let's go back to our graph and plot that point. 0 on the x, -2 on the y. Now here's where the axis of symmetry is going to help you. First of all, I can see now that my U is opening up, right? Because this vertex is either the highest or the lowest point. So if I get a point up here, it means it's going to open up like a regular U. How far to the left from the axis of symmetry is this point? One space, right? I see your little 1 fingers. Okay, guess what? There's going to be another point on the other side, 1 space over. I just mirrored it. I don't need to go find that point. Now, I do need one more. I want you to have the vertex, 2 points on one side, and then you just mirror those 2 points on the other side. So you're still getting 3 points. The vertex and 2 on a side, and then 2 mirrored. So I've got 0. If I want to keep going to the left, maybe I do -1. I want to find out where my -1 is. Now again, be careful with this. With a negative, when you're doing all your PEMDAS, plugging this in, I'm going to leave some of that PEMDAS for now. This is what it would look like. Go carefully. Watch your negatives, go slowly. You guys know how to do this, so don't make the mistakes on this part. Go slowly enough. If I plug in a -1, you'll get a +1. Again, you, of course, showing all your work. So -1 for x, +1 for y, that's my final point that I need to get. I'm going to come to -1, +1. So again, -1 on the x, +1 on the y, there's my final point. Now, from the axis of symmetry, my dashed line, how many spaces is this to the left? To the left, to the left. 2, right? Not the main y-axis, the axis of symmetry, 2 over. So all we do from the axis of symmetry, 2 to the other side. You mirror the point on the other side from the axis of symmetry, not the y-axis. And now, I connect my dots, and I put arrows going up to show that it's going to keep on going. Now, I'm just going to kind of summarize here. We're only going to do that one example, but I need to show you there's going to be a quick way to know if it should open up or down, if it should be a regular U or an upside down U, and I'm just going to give you a couple little steps to follow in case you lose track of where do I start. Okay, so I'll move this down. If anybody needs to see my little graph again, go ahead and ask and I'll put it back up. Okay, final things to know. Remember that A is the very first value. That A is multiplied by the x squared. Okay? If A is positive, a positive number, you get a regular looking U. Now it might be wider, it might be skinnier, but it's going to be facing up. If the A value is a negative number, then you get the upside down. And so when you get your vertex, then the rest of your points would go down below it. But it still has an axis of symmetry either way. Okay? The other thing I just want to show you before I give you just a couple final steps to follow is that you're going to see some of these as functions. I wrote y equals and then all the x squared minus x minus all that stuff. Let me just tell you that in your book, some of them have this function notation. So instead of y equals, it might say h of x equals. And then it has your trinomial over here. If you see one with function notation, where they name it as a function, this h parentheses x or g or whatever they do, whether they could use the equals, they could use the arrow like you saw yesterday, this is your y. When we're talking about graphing, we need a y value, an x and a y. If they show this, just write it down as a y in your book. Right? On the last one we did, we said y equals. So if you see function notation, just swap it out for y equals. And if they use the arrow, like we saw yesterday, swap it out for an equal sign. Okay, so just to finalize, find the first step. Find the x coordinate, I'm abbreviating there, of the vertex. That's going to be your first step. That's the negative b over 2a part. Use the x coordinate in a chart to find its y coordinate. And again, I'm just abbreviating coordinate. I think you guys will remember what that means, I hope. So your first step is going to be to use that little formula to find the x coordinate. Then you set up your chart. You plug in that x coordinate in the chart to find its y coordinate. And then you plot the vertex. That gives you the vertex. Either the greatest, the upper one, or the lower, depending on the way the u is facing. Plot the vertex. Draw the axis of symmetry. Remember, that's going to help you not have to plot so many points. You just mirror. So plot the vertex point, draw the axis of symmetry through it. You're going to want to do a dashed line so you don't confuse it with the y-axis. Find 2
points on each side. And then I'm going to put in quotation marks, mirror them. So just like I did, I found 2 on the left and mirrored them on the right. It doesn't matter which way you go. You can mirror them around that axis of symmetry starting from either direction. Parabolas.